students, let me welcome you all to my first general revision of physics. In this edition, you will be encountered with multiple choice questions. Questions of gradual difficulty. Actually, some of them require deep thinking, deep thought, and intense concentration. I'll give you time to think, and hopefully you'll find it interesting and useful. So let's get started. First question. The value of the current I1 in the opposite circuit. Your attention, please. Yes, there's something very important. Internal resistance here is equal to 0, and we've got just two resistors connected in parallel. We don't have any more resistors, so the voltage of the battery will be the terminal voltage. So voltage across 3 ohm resistor is 6 volt, and across 2 ohm resistor is 6 volt. And we want to calculate I1. So it's all easy. Yes, thank you very much. It will be, is it 2 ampere, 3 amperes, 6 amperes, or 0? Of course, 6 over 3, it is 2 amperes. Another choice, in an AC dynamo, if the time taken by the AC current to increase from 0 to half its maximum value is T. The time taken by the current to increase from 0 to its maximum value, is it T, 2T, 3T, 4T seconds? This is very important, yes, piece of information here. Okay, it needs deep thinking, and I'll give you enough time. Is it 2T, 2T, 3T, or 4T? Your attention, and please write the following piece of information. It is 3T. The question is why? Time to reach the maximum is equal to 3 times as great as the time to reach half the maximum. Why? Because the current, it changes sinusoidally according to sine wave. Your attention, please. Okay, instantaneous EMF equals maximum EMF sine theta. Okay, instantaneous at a EMF instantaneous at a certain point equals half EMF maximum. Okay, so EMF maximum sine theta, EMF maximum will be cancelled out, so half equals sine theta 1 equals 30. And now we want to know the time to reach maximum, not half the maximum. Okay, so by the way, any angle equals 2 pi ft. We managed to obtain T1. And at the time when an instantaneous equal EMF maximum, okay, so following the rest of the equation, EMF maximum sine theta, EMF maximum will be cancelled out. So sine theta 2 equals 1, theta 2 equals, yes, 90. So 90 equals 2 pi ft. Now we can compare the 2 times, T1 to T3. So it's quite clear, when comparing T1 to T2, it is 3 times, yes, as T1. Okay, if the maximum value of the EMF induced in an AC dynamo is 100 volt, the average EMF induced in a quarter of a cycle equals average EMF. Yes, is it 100 or 63.63, 50 or 157? The question is this, do we have a relation that relates maximum and average EMF? Of course, yes. Your attention, please. EMF maximum, you should memorize this, equals EMF average times pi over 2. Times pi over 2. Okay, so EMF average equals EMF maximum times 2 over pi. Given in the problem, EMF maximum equals 100, so it's all easy to calculate average EMF. It is 100 times 2 over pi. It will be 63.63. Another choice. Now we've got a circuit. What about this circuit? It contains, yes, parallel combination that consists of 3 resistors, 8, 8, and 4, connected in series to 1.5 ohm resistor, and internal resistance 0.5. Okay, what about the question? Of course, we want the value of I2. Okay, the value of I2, the current passing through 8 ohm resistor. Is it 0.25, 0.5 ampere, or 1.5 ampere, or no correct answer? It is 0.25 ampere. First of all, we need to calculate total resistance and current through the battery. We'll do it one by one. Okay, so total resistance equals 8 and 8 and 8 connected in parallel will give a resistance of 2. Okay, plus 1.5 plus 0.5, so it is 4 ohm resistor. Now it's all easy to obtain the current passing through the battery using Ohm's law of closed circuit. Current passing through the battery equals V battery over R total. So it is equal to 4 over 4, 1 ampere. And to calculate the current in a combination connected in parallel, we need to calculate the voltage across this particular combination. Okay, the voltage equals current times the resistance of this combination only. So potential difference across the parallel combination equals 1 times R equivalent of the parallel combination. Okay, so it is equal to 1 times 2, it is 2 volt. Now it's all easy to obtain the current. The current equals voltage divided by resistance, voltage 2, resistance, yes, is 8. So it is 2 over 8. It is 1 over 4. 1 over 4, of course, it is 0.25. Another choice, the ratio between the wavelength of the maximum intensity of the sun to that of the earth, is it greater than, equal to, less than 1? We are comparing wavelength of the, yes, sun to that of the earth. I guess it is easy, so the answer is less. Another choice, in Compton effect, the ratio between the velocity of the incident photon just before it collides with the free electron, okay, and the velocity of the scattered photon, is it greater than, equal, less than? Your attention. Light travels scattered or incident with the same speed, so the ratio must be equal to 1. So it is equal to 1. Another choice, we've got a circuit here, a parallel combination. One arm consists of 4 ohm resistor and 2 ohm resistor connected in series, all of them connected in parallel to 3 ohm resistor. The parallel combination is connected to 1.3 ohm and internal resistance 0.2 ohm. Total voltage of the battery 10.5. We want the current passing through the 2 ohm resistor. Your attention, please. Okay, is it 1, 2, 3, or 4 ampere? Okay, once again, it is 1 ampere, but we need to do it one by one. First of all, and the current also through the 3 ohm resistor, it is 1, 2, or 3, or 4 ampere. Yes, it is 2 amperes. How? We'll do it, as I said. First of all, we need to calculate the resistance. Resistance of 4 and 2, it is equal to, yes, 6 ohm. Resistance of 6 and 3 connected in parallel, it is 2 ohm, product over the sum. And total resistance of the circuit equals 2 plus 1.3 plus 0.2, it is 3.5 ohm. Now it's all easy to calculate the current passing through the circuit. Current passing through the battery equals, yes, 10.5 over 3.5. It is 3 amperes. Okay. And now we need to calculate the potential difference across the parallel combination. So potential difference across the parallel combination, it is 3 times 2. It is 6 volt. 6 volt divided by 6. Okay, this is very important. The current passing through the 2 ohm and 4 ohm, yeah, are making just one resistance of 6 ohm. So it is 6 over 6, 1 ampere. And 6 over 3, it is 2 amperes. Okay, to calculate the current passing through the 3 ohm, 6 over 3, as I said, it is 2 amperes. Okay. A dynamo coil takes time t to rotate from 0 position, vertical position, till half the maximum EMF is induced. The periodic time of its rotation, is it? This is very important. Your attention, please. I said some of the questions require deep thought and intense concentration. This is one of them. Okay, a dynamo coil takes a time t to rotate from 0 to half maximum. The periodic time equals 4t, 8t, or 12, or 16, 12t. So how? This is important. You'd better jot it down, write it down. I'll explain it. Okay, now the angle of rotation from vertical position, time, and value of the instantaneous EMF. Your attention, please. Just stay with me. Okay? When the angle is 30, okay, say the time t1, the value is half the maximum EMF. And we've just, yes, solved one. We've just answered a choice depending on this. Okay, so to reach half the maximum EMF induced, the angle should be 30. Angle of rotation of the coil of the dynamo from the vertical is 30. Okay, to reach maximum, the angle should be 90. Okay, to reach the effective value, the angle should be 45. These are very important pieces of information. Let it be T3. EMF is then maximum. And what about the time, periodic time? Periodic time, time to complete one revolution, making an angle 360. And now, okay, at this particular moment, instantaneous is equal to 0 since it is starting from the vertical. And now we can compare, yes, 360 to 30. What about when dividing 360 by 30, it will give 12. Okay. And I advise you to write this slide, this shot. This is very important piece of information. Okay. So comparing periodic time with T1 time half the maximum, okay, it is 12. Comparing periodic time with time the maximum, it is 4, yes, 4 times as great as, okay? Periodic time to the effective, it is 8 times as great as the time of the effective. These are important things. You should know it and you should write it down. Okay. Another choice, the equivalent resistance of the opposite circuit is, okay, I think it's all easy for you to do it, okay? We've got 2 branches connected in parallel. You pay attention to the 2 nodes, 2 junctions where the current enters and leaves. It enters at point A and leaves at point B. So 3, 6, and 3 form just one resistor. Yes, one resistor of resistance 6 plus 3 plus 3, 12, parallel to 6. So what about the equivalent resistance? Yes. Is it 3, 4.5, 4, or 12? Of course 4. Why? As I said. And what if the current enters at A and leaves at C? Okay? So we've got 3 and 6 forming a resistance of 9 connected to 9 also. So will it be 3, 4.5, 4, or 12? I think it's all easy for you. 9 and 9 connected in parallel. 9 over 2, it is 4.5. Okay. In photoelectricity, the graph which best represents the relationship between the intensity of photoelectrons and the intensity of the incident light, intensity of the electrons ejected, and intensity of the incident light, when the frequency is less than the threshold frequency. When the frequency is less than the threshold frequency, no emission of electrons, no matter how intense they are. This is very important. So what about the graph that best represents the relation between the two intensities? Intensity of the incident radiation and intensity of the photoelectric current. Okay, I'll give you time to think. Is it A, B, or C and D? As I said, it has no effect, the intensity, whatever the intensity. Okay, so the graph must be B. Okay, thank you very much. Another choice, thermionic emission is radiation of heat by a hot wire, emission of electrons by a hot wire, emission of electrons by a metal source due to incident light, bombardment of a metal target by electrons. Of course, it is emission of electrons by a hot wire. And this is very easy. Another choice. In photoelectricity, the graph which best represents the relationship between intensity of the photoelectric current and intensity of incident radiation, but now the frequency is above, so we've got direct relation. Okay, is it A, B, C, or D? As I said, as long as the frequency is above the threshold, above the critical, so as intensity increases, intensity of incident radiation increases, intensity of photoelectrons also increases. So it must be A. Okay, another choice. A wire of resistance R is reshaped so that its area becomes N times its original value. What will its new resistance be? Okay, by the way, when reshaping a wire by a change in length, actually we've got two factors. Length and area. When you reshape a wire, we've got two factors affecting the resistance of the wire. Length and area. And the relation between them is an inverse relation. Okay? What about the choices? Is it R, N squared R, N squared over R, or R over N squared? Okay, your attention please. We'll see the right answer, how we managed to obtain it. R equals rho EL over A. A2 mentioned in the problem equals N times A1. And so length should be, as we've got an inverse relation, second length equals 1 over N L1. And now we've got two factors, R2 over R1. Relation between R and length is direct. Okay, so L2 over L1. Relation between R and area is inverse, A1 over A2. And substituting now, L2 over L1 equals 1 over N. A1 over A2 equals 1 over N, so it is equal to 1 over N squared. So R2 equals R over N squared. Okay. Another choice. Okay. Now your attention, we've got very important questions. And the key answer is to look at the internal resistance of the circuit. Internal resistance of the cell of the circuit. Do we have an internal resistance? Okay, we've got something here important. Unless mentioned that the internal is neglected, actually it is found. Okay, so here we've got the internal resistance equals 0. And the question is, the value of R1 is decreased. What will happen to the readings on the ammeter? Okay. This is very important. Internal equals 0. So V battery is the voltage across R1, and it is the voltage across R2. Okay. R1 is decreased. So total resistance is decreased. Total current must be increased. So A1 increases. Okay, great. And what about A2? A2, as I said, the voltage is the same. Resistance is decreased, so A2 must increase. A2, the current passing through R1, it is calculated by VB divided by R1. R1 is decreased, so A2 is increased. And what about A3? Same voltage, it is the voltage of the battery, V battery. The resistance is unaltered, unchanged, so A3 is unchanged. So once again, A1 increased, A2 increased, A3 is unchanged. So the choices, A1 increases, A2 decreases, A3 unchanged, A1 decreases, A2 decreases, and A3 is unchanged. I explained it. Okay, so the right choice is, yes, number C. A1 increased, A2 increased, but A3 is unchanged. Okay, your attention to the next one. The value of R1 is decreased. Okay, but now we've got an internal resistance. Now we've got an internal resistance. What will happen to the readings on the ammeters? Your attention, please. Okay, R1 is decreased. R1 is decreased. When the resistance of one branch is decreased, total resistance is decreased. Current passing through the battery increases. Internal voltage, which equals I, R small, increases. So terminal voltage decreases because the sum of internal and external equals V battery, a constant which is V battery. Once again, your attention. Decreasing the resistance of one branch means decreasing the resistance of the total circuit. Current increases, internal voltage increases, terminal voltage, yes, decreases. Okay, now we can do it. So terminal voltage decreases. Okay, R2, your attention, as I said, A1 is increased, total current. Terminal voltage across R2 is decreased. So the current, yes, across A3 is decreased. How to explain that? Total current is increased through, though A2 is decreased, so though A3 is decreased, so A2 must be increased. Let me say it again. Resistance, R1 is decreased, total resistance is decreased, current increases through the battery, A1 increases. Terminal voltage decreases. Terminal voltage decreases, it is the voltage across R2, so A3 should be decreased. The question now, A1 increased, A3 decreased. How come? A1 is equal to A2 plus A3, so A2 must be increased. So A1 increased, A2 increased, A3 decreased. This is very important piece of information. Okay, A1 increases, A2 decreases, and A3 is unchanged. A1 decreases, A2 decreases. I explained it, it is number C. A1 increases, A2 increases, and A3 is decreased. Another choice, the angular speed of rotation of an armature of alternating current is doubled. Then the induced maximum EMF, will it be doubled, quadrupled, halved, or unchanged? Of course, it's all easy. It is doubled. Okay. Another choice, the least time at which the value of the current equals its effective value. Okay, least time. It is 2.5 times 10 to the power of negative 3 seconds to reach effective. the least time taken by the AC current to increase from 0 to half its maximum. We've got, yes, certain choices, 5 times 10 power negative 3. The right answer is 1.666 times 10 to the power of negative 3. The question is why? As I said before, we've got very important piece of information. I explained it and I'll do it once again. Angle from vertical position, time and value, as I said. When the angle is 30, yes, let it time be T1, value equals half the maximum. When it is 90, so it is maximum. When it is 45, it is the effective, okay? When it is 360, it is the periodic time. And now we want to compare the, yes, time where the EMF is half maximum and time where it is effective. So stay with me once again. We'll concentrate on two things. Angle 30, time T1, okay? Angle 45, let time be T3. Now we can compare the time. So T1 equals 2 over 3 T2, okay, 2 over 3 T3, so it is 2 over 3 times the time given, 2.5 times 10 to the power of negative 3. It is 1.6 times 10 to the power of negative 3 second, of course. In this way, we've come to the end of this edition. Before I leave, to revise, I just want to say to revise effectively, you need to ditch your mobile, to get rid of it, to place it in a different room and turn it off so as not to be distracted by your friends. Studying alone is most effective. Studying with your friends is less effective, and it's never too late to start. Then never give up, okay? Best of luck to you all. All the best. Goodbye.